Okay, so now we're going to solve a proportion. What is the trick to solving a proportion? What's the shortcut you can use?
You can multiply across.
So you can multiply the 6 times what?
The 7x plus 4.
Good. And then you can multiply the 5 times what?
The 9.
Good. Do you know why that works?
No.
You're actually just multiplying by the LCD. So the LCD here would be 5, 7x plus 4, right?
Okay. Yes.
If you did it the other way. And I'm not saying you have to do it this way. I just figure you might as well know why you're doing what you're doing. All right. If you did that, the 5s would cancel out. So you would just be multiplying the 6 by the 7x plus 4. And the 7x plus 4s would cancel out. And you would just be multiplying the 9 by 5. So instead of writing out that process every time, we teach you the shortcut that you can just do the cross product. Okay. But it really is just based on doing the LCD.
Okay.
So just in case you were curious. Sometimes it helps me to understand why I'm doing something, right? Like, why does this work? So that gives you the background. Okay. So when you distribute 6, what do you get?
You get 42x plus 24.
Equals?
45.
Okay. And then what would you do?
You'd subtract the 24.
So 42x equals?
21. And then you would divide the 42. 1/2.
Very good. 42 is 21 times 2, so it would reduce down to 1/2. Excellent. So now we're going to do some word problems with rational equations. Isn't this exciting?
No.
At least you're honest, right? That's all I can ask for. Okay. A company found that an experienced surveyor can survey a roadbed in 5 hours. An apprentice surveyor needs 8 hours to survey the same stretch of road. If the two work together, find how long it takes them to complete the job. So in theory, what should happen here? If they work together, what should happen?
You combined.
Yeah, so in theory, is it going to take longer or shorter?
Oh, if they work together, I think it would take shorter, right?
Exactly. It should take shorter than the faster person, right? Because if the faster person can do it in 5 hours alone, then we know, okay, our answer should be less than 5 hours, right? If the guy helps out. Although I always joke that you never know, sometimes 2 people get together and it actually slows them down.
That's
right?
true.
Has that ever happened? You try to study with someone and you spend half the time studying and half the time giggling about nonsense or whatever.
Yeah.
So, I mean, we've all done it. But that's okay. So, okay, we have an experienced surveyor and an apprentice surveyor. So I'm going to make a chart. You don't have to make a chart, but if it helps you, I definitely recommend it. So the experienced surveyor, the time to complete the job is 5 hours. Okay, the apprentice takes 8 hours. With me so far? So the time to complete one job, if it's 5 hours, then the part of the job completed in 1 hour, you're going to do the reciprocal, right? Because if you can do the job in 5 hours, that means in 1 hour, you do 1/5 of the job, right? Because then if in each of those 5 hours, you do 1/5 of the job, then you've done the whole job in 5 hours, right? So to go from the first column to the second column, it's always the reciprocal.
Okay.
Okay, so then if the apprentice can do the whole job in 8 hours, what part of the job can he do in 1 hour?
It would be 1/8 for the apprentice. Yeah.
So then we don't know how long it takes them if they work together. So I'm going to call that X, but then what would be the reciprocal of X?
1/x.
Good. So then this is the equation that we're going to solve to figure out the original solution. So we're going to do 1/5 plus 1/8 equals 1/x. Okay, and then we're going to solve it by doing what we've been doing, finding the LCD. So what would be the LCD here?
It would be 40x.
Good. So we're going to multiply that to every term.
It would be 8x
Mm-hmm.
plus 5x equals 40.
I managed to mute myself. Okay. 8x plus 5x is?
13x.
There you go. Divide by 13. By the way, you can leave your answer as an improper fraction, so they will accept this answer. I know if you get it wrong, they tend to show a mixed number as the final answer. So if you got this question wrong, the computer would probably show you this because they would figure out how many times 13 goes into 40 by doing like long division, which would be 3 times, and then the remainder would be 1. So that's where the numerator would come from. But they will accept the improper fraction. You do not have to convert it to a mixed number.
Okay.
So let's check out the next problem. A lot of blanks to be filled in here. A jogger begins her workout by jogging a distance of 8 miles. She then jogs home at the same speed along a different route that is 12 miles. Her time is 1 hour longer. Find her speed. Her rate, if we're using the letter R, her rate is the same going to the park and coming home from the park, right? That's what they tell us in the problem. So our rates are both going to be R. But let's use this. We know that distance equals rate times time. And anytime you're filling out a distance, rate, time column, you're really only filling out 2 of the columns, and then you're using those 2 columns to figure out the 3rd column. So in other words, back in the day, in I think the first module, we would fill in the rate and the time, and then we would multiply them together to fill in the distance column, if you recall doing that. So now this time what we've done is we've filled in the distance and rate column, and we're going to use those to fill in the time column. So we have to solve for time here. So if you divide both sides by rate, you see that time equals distance divided by rate. So the distance was 8 for the trip to the park. The rate was R. So the time would then be 8 over R. Okay. And then how would you fill out the time for the return trip?
It would be 12 over R.
Good. Okay, then the key thing that's going to help us write the equation is that the return trip is 1 hour longer. So what equation could you come up with here?
1 plus X.
1 plus what? So we're going to be using this column.
1 plus R.
So we're not going to just use R. The times are 8 over R and 12 over R. So that's what we're going to be using. So let's think about it for a second. Okay, if it says, let's just think about it in terms of words. If the return trip is 1 hour longer than the trip to the park, are you going to put 1 plus trip to the park equals return trip? Or are you going to put 1 plus return trip equals trip to the park? Which way?
It would be the 1 plus the return trip. Right?
Okay, so you're saying 1 plus the return, the time for the return trip. I'm leaving that out, but assuming that's understood, equals the time for the trip. Now go back and read your sentence and see if that makes sense. It says the return trip is 1 hour longer. So give me some actual numbers. Let's say guess how long it takes her to get to the park. Just pick a random number. Just pick it. It doesn't have to be right. Just pick your favorite number. It can be 147. It can be your number from earlier. It doesn't
24.
matter. 24. Okay. The number doesn't have to make sense. Okay.
Okay.
Let's say that's how long it took her to go to the park. If her return trip is 1 hour longer, how long would it be?
Oh, it would be 25.
Okay, so does 1 plus 25 equal 24?
Oh, no.
No, so it's actually the other way around, right? So the key thing here is you actually have to do 1, if it's 1 hour longer, it means that you have to actually add 1 hour to the other time to equal its time. So 1 plus time for trip to park is going to equal the time for the return trip. because now if you pretend that it takes 24 hours to get to the park, which obviously is ridiculous, then if you add 1, we'll pretend it's minutes or something, who knows, then it would equal 25. It would actually work.
Okay.
Okay, so now you have to plug in these values. So instead of writing time for trip to park, you're really just going to plug in the 8 over R, right? Because that represents the time for the trip to the park. And then the time for the return trip was 12 over R. I'm just borrowing the information from the chart.
Okay.
Okay. This is definitely a very tricky equation to set up. So
Yeah.
you're
I
not
struggle
alone
with
in
word
feeling.
problems anyways, so.
Yeah, word problems are tough to set up anyways, and this one is not completely like straightforward, so it makes it even harder. Like these ones, the one we just did with the work, once you kind of figure out a pattern, they kind of all flow the same way, right?
Yeah.
But this one's definitely a little tricky. Okay, not too bad to solve though, once you finally have an equation. So how would you solve it?
You'd multiply by the LCD.
Which is?
R.
So what does that give us once you do that?
So you'd have R plus 8 equals 12.
There you go. So R would equal?
R would equal 4.
4. And then what would be the units for the speed? Would it be miles, hours, or miles per hour?
I don't know. I can't see the word problem. Is it miles per hour?
Yes. Very good. Because your speed is always going to be like a distance per a time. Okay, so now we have a few more problems. Let's see, 2 more word problems where we're going to create the chart ourselves. The initial part and then the cool down part. So what rates did they give us?
You got 4 miles per hour.
I lied. So I mean, okay, yeah, we can use that, but they give us the distance. I don't know why I said they gave us the rate.
Oh, you're talking about the distance.
Yeah, but I said the wrong word.
Miles.
So you answered me correctly. So yes, 26 miles initially, and then the cool down was
18.
18. I like to start with like the easiest part, if that makes sense. The part
Yeah.
that we can like directly get, so we can be like, okay, we got 1 column down.
Yeah.
Okay. Find the speed. Okay, so if you want to let the variable be the rate, which is fine, then if the initial speed was, what letter do you want to use for the rate?
We'll just use X.
Okay, if the initial speed was X, what was the speed during the cool down period if he reduced his speed by 4 miles per hour?
So would you do 4 minus X?
Close, except think about it. Let's say he was going 20 miles an hour. I guess that's pretty fast, but whatever. We're just making up numbers. What would be the new speed if it was?
So then you would do X minus 4.
Yes.
I always get that confused.
Try to do it. Do you notice that once I give you numbers, you can kind of make sense of it? So try to do that yourself in your head, right?
Okay.
Like, okay, if the one, just like I said, literally pick a random number. It doesn't matter if the number makes sense in the context of the problem. And then be like, okay, well, when I subtract 4, I certainly don't want to get a negative answer. And if I did 4 minus 20, that would be negative. So I know that's wrong. So, okay, it's the other way, right? Sometimes that'll work and you'd be able to do that on your own. Okay, if we know the distance and rate, how can we figure out the time?
So the time, would that be a 1 over X for the initial?
Okay, so what you have to do, if you recall, remember you only fill out 2 columns, which we've already done, and then you use them to figure out the 3rd column. So you go back to what we were saying a minute ago, that distance always equals rate times time, correct? So then how could you solve that for time? How could you get the time by itself?
You divide it.
You divide by R, right? So then time ends up equaling distance divided by rate.
6 over X, right?
So 26 over X. Good. And then the other spot?
18 over X minus 4.
Okay, so you're only ever filling in 2 columns for the distance, rate, and time, whatever 2 columns you can, and then use those 2 columns to come up with your 3rd column.
Okay.
Then go back to the problem to figure out the relationship. So in the last problem, it said something was 1 hour longer. Here, thank goodness, it actually says something even more helpful, which is what? What does the problem tell us about the time?
That they took the same time.
Yes, which means we can do what with the 2 time expressions?
Can you turn this into like a proportion?
Yes.
Okay.
Because the same is another way of saying equal, right? So you can set them equal to each other. Exactly. And then you could absolutely solve it like a proportion, which is also nice, as you said. So what does that give you when you cross multiply?
All right, so we got 26x minus 104 equals 18x. I would subtract the 26. So you have like the negative 104 equals negative 8x. And then divide the negative 8. And that comes out to a positive 13.
If you look back at your chart, what does x represent?
The rate.
The rate of which one?
Of the initial.
Of the initial or the first portion. So that would be your first answer, 13. And then once again, this one's going to be miles per hour. Okay. And then for the cool down portion, how are you going to figure that out?
You would do the 13 minus 4.
Which would give you
9.
9. So each problem is different, as you'll also see with the next problem, but there are also some similarities in these distance, rate, and time problems as well. So let's try the next one. We're going with the wind and against the wind. So let's start with the easy part, which is the distance again. What is the distance we're traveling with the wind?
486.
And how about against the wind?
396.
Now for the rate, they tell us the rate in still air, but we also need to identify the rate of the wind, right? So if the rate in still air is 245, let's use x to represent the speed of the wind, okay, since that's what we're ultimately finding. So if you're going with the wind, does that mean you're going faster or slower?
Faster.
Faster. So what do you think we have to do with the x and the 245 if we're going with the wind?
You'd subtract the 245? Well, that's still air though. Wouldn't that be subtracting it?
So still air is like if there was no wind at all, the plane would be traveling 245 miles per hour. Right? But if you think of like pretend you're running instead of a plane, right? If you're running and the wind is like helping you, you're going to go faster.
Oh, you're going to add it.
You're actually going to add it. So you would take 245 and you would add x because the wind is actually causing you to go faster. Whereas if you're running into the wind or flying into the wind, that's when you're going to subtract. So you're going to take the 245, which is the initial speed, and subtract. Let's pretend the wind was 20 miles an hour. You would subtract that.
Okay.
Okay. How do we figure out the time if we have the distance and the rate already filled in on the chart?
You would divide it?
Yes, very good. So what would it be in the first time for with the wind?
It would be 486 over the 245 plus x.
So are you starting to see kind of like what I said, that there are some similarities to each problem, even though there's obviously difference as well, but this is one thing that they all have in common is that to figure out the time column, you're dividing the distance by the rate. So then the other one would be 396 over 245 minus x. Some big numbers here. What's the good news once again, just like the last problem?
You can set them both equal.
Because it says the same amount of time. Oh, and I already wrote over there, so we'll do this one here. Okay. 486 over 245 plus x equals 396. Imagine if you had to do this without a calculator.
Oh my. That would not be
Yeah.
fun.
No, thank you, right? Thank goodness for calculators. I personally do not even want to multiply 486 by 245. Like, no part of me would want to do that without a calculator. Okay. Can I? Yes. Can you? Yes. But why? Okay. So 486 times 245.
I got 119,070.
119070.
Yes.
119,070. Okay. Minus 486x equals, and then 240. Yeah, go ahead.
97,020 plus
Plus
X.
396x. Okay. So now let's subtract, or which way did you do it? I can match you. It doesn't matter if you do this.
I would probably just subtract the 97,000.
Okay. That was my first instinct, but it doesn't matter. So I didn't want to mess you up if you had done it a different way. Okay. What does that give you when you subtract that?
22,050.
Good. That I can confirm. Okay. Now what?
So add the 486 to the 396.
Which is?
882.
Okay. I'm hoping this divides evenly.
And then you divide them. You get 25.
25, and then once again, it was miles per hour. Okay, so other than the numbers being ridiculously large, any questions there?
No.
Okay.
Well, would you have to add to find the rate? Wasn't it to find the rate?
So they asked you for the speed of the wind.
The speed of the wind.
Which was the X. But if they asked you for the rate with the wind, it would actually be like 270, or the rate against the wind, right? If you subtract 25, it would be 220. But they actually just asked you for the speed of the wind, so 25 is your final answer.
Okay, that was my question.
It would literally depend on what they asked there. So what I circled, if they asked for something different, then you might have an extra calculation at the end.
Okay.